This is a 7-mark question on kinetics. It has two parts, A and B. I'm going to recommend you pause, try, and then review. So here's part A, and here's part B. So in part A, we've been given the rate equation for the experiment with compounds C and D, and we've also been given lots of data as well. Now, your job is to calculate a value for the rate constant, K. So we need to make K the subject, and we rearrange the equation, and we get that K is rate over concentration of C times concentration of D. Now, when you look at all of the data that we have, you can see that we have all of those figures ready to slot straight in. We've been given the initial rate of reaction, and we've been given the initial concentration of C and D. By putting all of that together, I can find my value for K. I've actually got 2 marks so far, one for the working out and one for calculating the rate constant. But I still need the units. Now, I'm going to show how you can do that. You can substitute the units into the expression. We've got mol dm to the minus 3 s to the minus 1 over mol dm to the minus 3 squared. Mol dm to the minus 3 cancels out on the top of the bottom, so I have s to the minus 1 over mol dm to the minus 3, which, rearranged, gives mol to the minus 1 dm3 s to the minus 1. Moving on to part B, we have got a different expression, but you've been given a full expression here that you can then rearrange. We're wanting to find out the activation energy. Now, to start with, we have calculated the value for K, and we need log K. This is natural log K in this case, so it's the ln button rather than the log button on the calculator. But if you put that in, you will get a value of negative 3.58. Now, if I rearrange my expression that's been provided to make EA the subject, that's the activation energy that we're calculating, we end up with RT multiplied by log K, take away log A. Once again, I can put lots of figures in. We have the R value provided, we have the temperature provided, which I've remembered to convert to kelvins. We've just calculated log K, and we have been provided with log A. And when you work that out, you will get to a negative EA value of negative 51. Now, you've got to be really mindful not to stop at that point. They are negatives, which means that the EA value is 51 kilojoules per mole.